Amidst the mud and chaos of the First World War, where steel giants sank under their own weight, a solution was born. It was not a story of size, but of an idea that looked fragile but would redefine the battlefield forever. This was the Renault FT, introduced in 1917. Its revolution was not horsepower but layout. Engineers separated the engine to the rear, the driver to the front, and the weapon into a new critical component, the first fully traversable 360-degree turret in a production tank. For the first time, a tank could aim its gun without turning its entire body. It was a fundamental shift, a new grammar of war. At just 6.5 tons, the weight of 4 modern passenger cars, it was almost weightless for a tank of its era. But inside this tiny frame was a brutal human-machine interface. A crew of 2. The driver sat blind, navigating the shell-torn landscape based on directional kicks from his commander. The commander stood above, performing the roles of an entire gun crew. He was the spotter, the loader, and the gunner, manually cranking the heavy turret, aiming and firing in a steel box that grew red hot from its own engine. The space was a deafening, claustrophobic cell, filled with the roar of the engine and the sharp smell of cordite. But this brutal, efficient design worked. It became the template, the genetic code for nearly every tank that followed. Across all variants, more than 3,600 were built. But while the French bet on elegance and speed with their 6.5-ton FT-17, the British chose a different path. They chose brute force, embodied in a 28-ton steel monster, the Mark V. Its design was archaic, a pure instrument of attrition, a rhomboid shape with no rotating turret, tracks wrapped around its entire body, creating a profile built for a single purpose, to cross the shattered earth of no man's land. Its length was nearly 8 meters, the size of a modern city bus, crawling across the battlefield to crush wire and fortifications. From the outside, it was a fortress. Inside, it was a mechanical hell. The engine, completely exposed within the crew compartment, filled the steel box with a deafening roar and toxic fumes. 8 men were trapped inside, a moving coffin. Temperatures could soar past 50 degrees Celsius, 122 Fahrenheit. This was a dead-end branch of tank evolution, prioritizing brute intimidation over tactical flexibility. It was produced in 2 distinct versions, a male armed with cannons and a female equipped only with machine guns. The Mark V tank was clumsy, but it performed its function. The first French tank, however, the Schneider CA-1, demonstrated how a machine's greatest enemy could be its own design. The year is 1916. The concept is revolutionary, a self-propelled assault gun engineered to shatter enemy lines and break the deadlock of the trenches. Let's follow the process. A 13-ton steel box lurches toward an enemy trench. The hull tilts forward, preparing to bridge the gap, but the engineers made one fatal miscalculation. The low-slung steel nose is too long. It doesn't climb the opposite bank, it plows straight into it. A piercing screech of metal on earth. The machine stops dead, trapped. The engine roars in a desperate attempt to move, but 13 tons of armor are now just a stationary target for enemy artillery. It was a design-driven death sentence. The entire weapon system was also dangerously unbalanced. Its 75mm cannon was shifted far to the right, a design choice that felt like driving a car with half a ton of cargo strapped to one side. Every turn became a struggle. Every obstacle was a potential trap. So why did a machine with such a glaring fundamental flaw ever leave the factory? The answer reveals the frantic calculus of a war that had no time for second chances. An elegant hero, a clumsy giant, and a doomed experiment. These machines, however different, were born from the same nightmare. The nightmare buried in the trenches of the First World War. For years, the Western Front was a static line of carnage, a sea of mud and barbed wire stretching for hundreds of kilometers, where progress was measured in meters and paid for with thousands of lives. At the Battle of the Somme alone, over 1 million men became casualties to move the front line just a few kilometers. This was the deadlock, an unsolvable equation. Into this paralysis, engineers threw every possible answer. A lightweight revolutionary, a steel behemoth, a flawed assault gun. They were not products of calm, rational design. They were acts of desperation. Each piece of rusted metal, each flawed concept, was a frantic attempt to break the brutal stalemate of the machine gun. These were the symptoms of a global crisis, the physical proof of a world that had run out of conventional unconventional ideas. Today, they are relics, rusting quietly in museums. But they are more than just strange machines. They are the artifacts of a single, desperate question. The flawed designs were an attempt to answer. The failure of the Schneider CA1 proved that even a simple idea could be fatally flawed. But Italian engineers refused to make small corrections. They would build an absolute weapon, a true land battleship. Their answer weighed 40 tons, the Fiat 2000. This was not an iteration, it was a declaration. 40 tons. The weight of 7 adult African elephants balanced on a pair of tracks. Powering this machine was a 240 horsepower aviation engine, an immense power plant designed to move a rolling fortress. At its peak, a 65mm cannon rotated on the first fully traversable turret ever mounted on a heavy tank. A full 360 degrees of destruction. Below, 7 machine guns peered from hemispherical ports, creating an impenetrable web of fire. No blind spots, no safe approach for infantry. But the true engineering utopia was inside. For its crew of 10, this was a workspace, not a steel coffin. Mechanical ventilation systems cleared the air of cordite and engine fumes. The control levers weren't crude iron bars demanding brute force. They were engineered instruments, surprisingly ergonomic and precise. This was the ideal heavy tank of its era, a perfect weapon. It missed the war. The Great War ended before the Fiat 2000 could prove its superiority on European soil. So the ultimate weapon was shipped not to the front lines, but for trials in the harsh deserts of North Africa. While Italy engineered a palace on tracks, the Germans built something far more brutal, a mobile barracks. They called it the A7V, and they packed 18 men inside. 18 men! More than 2 starting football teams crammed into a 33-ton steel box. From the outside, it was a fortress. 30mm of frontal armor designed to shrug off machine gun fire and shrapnel, a rolling bastion of Imperial German power. But the real war was fought inside. The commander, perched on a central platform, screamed orders that were instantly swallowed by the deafening roar of 2 massive engines. 2 drivers fought with the controls trying to steer the behemoth. 6 gunners, each manning a heavy MG-08 machine gun, scanned their designated firing arcs, filling the compartment with noise and smoke. And then there were the mechanics, stationed inside the moving vehicle. Their only job was to keep the engines from seizing or catching fire. The air was a toxic fog. The smell of cordite from the guns mixed with hot oil, unburnt fuel, and the sweat of 17 other men. Every surface was either searing hot or vibrating violently. It wasn't a weapon system, it was an industrial hell on tracks. This crude, overcrowded, deafening instrument of war was Germany's desperate answer to the Allied tank threat. It was a failure in many ways, but it was destined for a historic confrontation. At Villers-Bretonneux, the A7V participated in the first tank versus tank duel in history. While the German A7V was a mobile fortress, at least it moved. The French Saint-Chamond, armed with a powerful 75mm cannon, often couldn't even reach the battlefield. Its entire problem was rooted in a single catastrophic design choice. The tank weighed 23 tons and stretched for nearly 9 meters, but its tracks were dangerously, disproportionately short for its massive body. This created a huge, unsupported overhang at the front where the heavy gun was mounted. The result was an engineering paradox, a machine with the body of a giant but the footing of a child. Physics became its executioner. As the Saint-Chamond approached a trench, its long nose would dip forward. The center of gravity would lurch past the point of no return, lifting the rear of the short tracks off the ground. They would spin uselessly. With a rigid suspension that offered no compensation, the vehicle would simply beach itself on the edge of the obstacle. 23 tons of useless steel, trapped by its own geometry. On the battlefields of 1917, this flaw was a death sentence for its mission. Deployed as mobile artillery, many units were simply abandoned after getting hopelessly stuck in the churned-up earth. They became static monuments to a fatal miscalculation. Decades later, a single intact unit was discovered, buried under the soil of a French forest. While French engineers watched their 23-ton Saint-Chamond sink into the mud, American designers posed a radical question. What if, to cross a trench, you didn't need armor at all? Their answer weighed just 9 tons. A machine built not from steel plates, but from the void between them. The skeleton tank. It was less a vehicle and more a mobile bridge, a lattice of pipes and beams connecting 2 sets of tracks. It weighed less than a single gun turret on some heavy tanks of the era. 4.5 times lighter than the Fiat 2000. Its purpose was singular: to master the trench. The front of its long frame would extend over the gap, finding purchase on the far side. Then the central armored pod, a tiny box for 2 men, would travel across the open structure, suspended over the abyss. Finally, the rear tracks would follow, planting the machine firmly on solid ground. Inside that pod was a crew of 2, but inside was a relative term. Wind whistled through the exposed steel frame. The ground blurred by directly beneath their feet, a constant, dizzying reminder of their vulnerability. Their only weapon was a single machine gun. Their only real defense was the hope that enemy artillery would miss. Was this a stroke of engineering genius, or was it simply madness? The war ended before that question could be answered on the battlefield. The project was canceled after only one prototype was built. Today, it sits motionless in a museum, a silent skeletal monument to an engineering gamble pushed to its absolute limit. The American skeleton tank showed that engineers were willing to sacrifice armor for a concept, but their German counterparts took a different path. They decided to turn armor into an indestructible fortress on tracks. Thus, the K-Wagen project was born, weighing 120 tons, the apex of gigantomania. It stretched the length of a modern city bus, but it weighed 120 tons. 2 Daimler engines generated a combined 650 horsepower. A brute force solution required simply to move this steel behemoth across the ground. Even then, the machine could only crawl, its rigid suspension transmitting every jolt and shock directly into the hull. It was a giant designed for a perfect world, a world without soft mud or shell craters, a world that did not exist. Inside, a crew of 27 men operated in a steel hell. The sound was a physical force. The roar of the twin engines mixed with the grinding of the tracks and the metallic echo of shouts inside a steel box. The commander screams orders that are instantly lost in the chaos. Deep within the hull, mechanics wrestle with the complex transmission, fighting the machine's immense inertia. In the gun sponsons, loaders struggle to feed the 4 77mm cannons as the entire fortress lurches and sways. It was a fortress. It was a tomb. A rolling bunker designed to be unstoppable, yet so massive it was practically immobile. A technological dead end. And although both prototypes were destroyed, fragments of one, found under concrete decades later, still make historians question the limits of engineering madness. The K-Wagen was a monster, but it at least stood on proven tracks. In 1914, however, Russian engineer Nikolai Lebedenko decided tracks were the past. His answer was the Tsar Tank, with wheels 27 feet in diameter. It was a giant tricycle from a Jules Verne nightmare. The 2 massive front wheels stood as tall as a 3-story building, their spoke design looking more like an element from a circus attraction than a weapon of war. The entire 60-ton structure was designed to provide an elevated firing platform, towering over trenches and enemy lines. On paper, the physics seemed plausible. In reality, it was a catastrophe waiting to happen. The entire weight distribution relied on a catastrophic miscalculation. The first test took place on a field outside Moscow. The machine lurched forward, its twin engines roaring. The immense wheels began to turn, pressing 60 tons of steel into the earth. But the fatal flaw was not at the front. The small 5-foot rear roller, designed only for steering and balance, dug into the soft ground and instantly became an anchor. The 480 horsepower engine screamed at their limit, but the machine was completely, hopelessly stuck. One test, one failure. The brilliant concept was defeated not by enemy fire, but by a patch of mud. It was a monument to engineering hubris, a machine so ambitious it ignored the most basic laws of ground pressure. The project was abandoned instantly. The giant machine remained at the site of its failure, rusting in a field for almost 10 years before being cut up for scrap. The Tsar Tank's failure was a 60-ton miscalculation. But what if the entire idea for a machine is a single colossal mistake? In 1915, French engineer Louis Boireau presented a mechanism that's difficult to even call a tank. This was the Boireau machine, a 30-ton tracked frame powered by a meager 80-horsepower engine. Its purpose was to cross trenches and barbed wire. Its fundamental flaw was everything else. The operator was not protected. He sat in a small, open cage at the center of the mechanism, surrounded by grinding gears and exposed shafts. A perfect target. The machine's propulsion system was a series of enormous articulating plates, which smashed against the ground with every rotation. The sound was deafening, announcing its presence from hundreds of meters away, nullifying any element of surprise. Yet its speed was agonizingly slow, 1 mile per hour, slower than a walking soldier. It was a weapon that couldn't protect its crew, couldn't move quietly, and couldn't advance faster than its own infantry. This was not just a failure, it was a mechanical monument to an era when the imagination of engineers completely detached from the laws of physics and common sense. The Bois machine, moving at a walking pace, became the high point of engineering absurdity. But it, like the other monsters of the First World War, left behind more than just rusted metal. They were expensive lessons, paid for in steel and human ambition. Each one marks a precise point where imagination outpaced technology, where the laws of physics delivered a brutal verdict on a designer's dream. We study these titanic failures not because they are strange, but because they define the very boundaries of invention. Success teaches us what works, but failure shows us what is possible. It exposes the gap between a blueprint and a battlefield, a gap that can only be closed by trial, by error, and by immense cost. So how many impossible machines must be built before one of them finally changes the world? If these stories matter, support the analysis.